Um, First of all, let's discuss the idea of inequalities and what they represent. You guys have seen that before this semester already with notation stuff, right? Like on a number line, how to show x greater than 1. That'd be an example of the solution set of an inequality. So I'm going to say solution set of an inequality is basically like the range of values that are being represented. So some examples of this concept would have been something like x bigger than 1. The solution set, it's always assumed to be reals unless my notation tells you otherwise. Remember that when you were learning set notation? So for something like x bigger than 1, you would say, okay, well here's 0, here's 1. Basically it's not including 1, but it is including everything to the right. And I remember some of you guys would actually use the parenthesis also in your notation. But the idea is still the same. It represents several values that satisfy the relationship we've set up. You know, so far when you were solving equations and things, you would get stuff like, hey, x equals 2, x equals 3/4, whatever it is you solve for x, right? But so far you've just gotten x equals one singular thing. The idea today is that x can take on more than one value. It can take on a range of values. So just like in the past when you were looking at this situation and graphing it, what this actually means is, hey, x can be more than one thing. In fact, it can be anything that satisfies this relationship that's bigger than 1. It could be a 3, it could be a 1.5, it could be 100. Anything that makes that relationship happy. Sometimes with solving for variables, just like here, you'll find that there's lots of solutions. Sometimes you'll find there's limited, maybe just 2 solutions. Sometimes later in math, you might find out, hey, it's everything. This thing's always true. Whatever. But the idea is there are more options, and today we're going to explore the inequality stuff. So when we have ranges of stuff. It won't always be written as easily as x greater than 1. You may have to manipulate it some to get it to look like that. But the goal is still to get x by itself while still being really careful with that sign in the middle. Because an equal sign, remember how an equal sign doesn't matter which side the x is on? The x can be on the right or the left, and it's okay. You know, x equals 4, and 4 equals x. Who cares? Same thing. Well, you know these things, these arrows are very specific to which one's bigger, aren't they? So when you're writing it and playing with it, you have to be very careful, or you'll get the exact opposite answer of what you're supposed to have. So let's look at a basic one. How about, I'm going to start off just by talking about adding and subtracting. Add and subtract to solve an inequality problem. And the idea is you're going to do it just like any kind of problem. We'll start off with simple adding and subtracting, and then I'll teach you how to multiply, divide, everything you've learned so far in this class. So with the adding and subtracting, here would be an example. If I told you, hey guys, I'm going to use the example in the book, x minus 1 less than 4. So here I'm describing a relationship with my variable and other numbers. Just like in the past when I had an equal sign, still a relationship. But we know that we want to get x by itself, just like always. What would you usually like to do here to get x alone? You would plus 1. Now guys, if you're still having trouble with algebra, if you still can't solve problems with an equal sign, you need to get help right now, because it's not going to get easier. The word problems, sure, they're going to trip us up. They're kind of challenging, and I know that. They're challenging for me sometimes too. But make sure you can solve with an equals or else you're behind, and you need tutoring. With this right here, sure, to get x by itself, you would have said plus 1, because you see x attached by a minus, and the opposite of minus is plus. So plus 1 on one side, and what would you assume you can do? Plus 1 on the other side. So the cool thing with adding and subtracting plays really well with these signs. Nothing crazy happens. You do exactly what you want to do with adding and subtracting. So yeah, I do say, hey, plus 1, same thing both sides. X is, now when I recopy this, I'm being very careful. X was on the left, it's coming down the left, and my sign, I'm copying it exactly. So x is smaller than 5. I'm too indecisive. I bring 2 drinks. Which one do I want? Okay, yeah. You could graph this solution, right? Okay. Similar to the one up in red. Let's look at one more example, though, just to make sure you guys are A-okay with this. What if we had that? First of all, is it okay that X is on the right-hand side? Does that change my problem, or is that still acceptable? It's still acceptable. You guys saw that in algebra problems with an equal sign. I mean, you still have to be careful with your sign and with where your X is in relation to the sign. But you can solve for X like always. We said you can add and subtract anytime with inequalities, and it won't tear anything up as long as you do the same thing to both sides. So if I want X by itself, what do I want to get rid of? Okay. You have a positive 4. Opposite of positive 4 is? Okay. I'll put negative 4 here, and then I'll also put it on the other side. So let's do that. Minus 4 over here, minus 4 on the left, and this cancels. 10 minus 4, I'm getting 6, bringing down my less than X. Now, if I wanted to graph that one, maybe that would be harder for me. I mean, the first one's pretty basic, I think. On the first one, remember I always told you guys, hey, if you're trying to decide which way to graph, you can look at it and say, hey, it looks kind of like an arrow pointing that way. Remember I told you that? So this one was really easy. The one on the left was really easy to graph because I just do what I would expect. 1, 2, 3, 4, 5. Open circle, color into the left. And that was supposed to be on the 5. On the 5. So that one worked just like always. But how am I going to graph this one over here? I mean, I'm definitely not coloring that way. If it made you more comfortable, could you write it with X on the other side? Oh, just be careful with your sign. So if the open mouth of your sign is towards the X now, if you write the X on the other side just for comfort, just for fuzzy feelings, you'd also turn the side, wouldn't you? Keep it consistent. You don't have to. If you're able to graph it based on how it looks now, you don't have to switch the thing. But for me personally, I'm more comfortable, I'm more happy if I do switch it. I prefer to see it like that. Because then I can do my little trick that reminds me, oh yeah, shade that way. The idea is, I just kept the sign pointing the exact same way to X. So see how its open mouth is towards X on both? I just had to keep that the same. You didn't have to flip it at all, Kel. But I did it because when I graph, I like to use the arrow trick. And X has to be on the left for me to use that trick, that shortcut for it to help me. So X is bigger than 6 always. So I'm going to go to 6, and it points this way. I mean, if I could have looked at this right here and said, oh, X is bigger than 6, you could have read it like that. You can see that relationship. So you still could have graphed it without having to rewrite it like this. I'm just more comfortable doing it the second way, writing it, switched. Doesn't matter to me, though, which one you do in here. It's the same exact thing. Just be careful with how you write that sign if you're going to recopy it. That's great. So we've said so far that as far as addition and subtraction go, do it like always. Do addition and subtraction like usual. Good news for us. But it does get a little bit different. Inequality stuff does change. And it changes when you get into multiplication and division. So when you go ahead, Carmelita. So when you're multiplying or dividing inequalities, Carmelita, if you want to speak, you have to hold down the F2 button, just so you know. That way I can actually hear what you're saying. I think in the future I need to set this up so like everybody can hear each other better. That'd be kind of a cool factor, but I don't know. Still learning it. So the idea with this is it works the same. except your sign will flip if you multiply or divide. What do you guys think? If I multiply or divide by what would it make sense to make my sign the opposite? Negative. We know that negatives kind of negate things and they make everything play funny, right? They cancel stuff. They mean the opposite. So if I multiply or divide by a negative. And when I say negative, I'm saying negative number, or you're just talking about -1, whatever it is you're using. Multiply or divide by a negative, and that's when you get the difference with these inequalities. You have to flip. That's the only really big difference that you're going to deal with first thing today. So for example, let's solve something like this. And I'm not going to start right away with ones that have to flip. I'm just going to remind you as we work to make sure that we don't flip, okay, on the ones that we don't have to. So let's try some examples now that I'm going to combine the adding and subtracting along with multiplying and dividing. I think double steps are okay if you guys are good at algebra with the first stuff, with the equal sign. 3x plus 2 less than -4. Okay, this is pretty basic, I think. So far it is, at least. It looks really similar to stuff I've seen in the past, except it has that sign in the middle. We don't have to care about the sign. We just know that our objective is to get x by itself, right? We only care about the sign when multiplying or dividing by a negative. That's the only time we play with that sign. So for now, let's just start moving stuff around. We start with what's least attached to the x. So what's least attached, the 3 or the 2? 2. How's it attached? The opposite of add is, okay. So I'm going to subtract 2 on the left and also subtract 2 on the right. Good. Nothing happened here. I can subtract 2. Nothing changes with my sign, does it? I'm going to bring it exactly down. Everybody okay? So less than, let's say I get 3x less than -6. See how I didn't do anything crazy? I want x by itself. That means I want to get rid of what? How's it attached? Opposite of multiply? Okay, so let's divide by 3 on both sides. Now I'm dividing by a +3. Is anything going to happen, or does the sign stay the same? Sure. So x, sign stays the same, because this was a positive, and I get -6 divided by 3 is a -2. So no flip, because I was dividing by a positive number.